So here's a pretty common curve. Joel, what kind of curve do I have here? I do have a cubic. Let's make it a nice one. Y equals to x cubed. This is our first question. Very common type of exam question, right? What they like you to do is that they'll give you a curve and they'll say, okay, from this, I want you to classify any stationary points. And we've looked at what that means, right? It means, okay, you have to first of all determine, right, a stationary point is when the gradient is equal to 0. So have that in the back of your mind. An inflection point, well, an inflection point is where the concavity changes. And we can see that there's very clearly a point where the concavity is changing, right? Like you look at this half, it's concave down. You look at this half, it's concave up, right? That's the visual understanding of what's going on. We're going to look at algebraically how that works. Same thing with part C. It's very easy to see this visually. How are we going to do this algebraically? Let's start off with part A, because we did that last lesson, right? Can I rub this side off here? Yeah. Okay, so part A, like classify any stationary points. Christian, can you remind me again, how do we find stationary points? So find the derivative, that's it, right? So you got your f of x curve. So we've got f of x is equal to x cubed. We'll take the derivatives. And so once we have the derivative, we let f dash of x equal to 0 for stationary points. I'm just going to say stat points. Okay? So at x equals to 0, we apparently have a stationary point, right? Now, remember that, first of all, is this a point? No, it's an x value, right? So, first of all, this is not even close to answering the question. The second thing is, how did we actually classify our stationary points? We had to do something in order to actually determine what type of stationary point this was. Yeah. Tables. Okay, a table is very important here, right? Because this alone is not enough to get you the classification. Like you actually have to draw that table up. And so we say, okay, there may be a station, there may be a minimum or maximum here, right? So let's test. What do you mean, sorry? The table is just it's like a common way of doing it, and it's just very clear, right? So if I have x, are you asking, like, do you have to draw it like this, or do you, what?
Like I've still worked it out.
Yeah, and not draw it in a table. Yeah. I mean, I don't think that would be wrong, but it's just like, I think the table is just easy, right? So 0, we'll test some points, right? So 0 is the point that's in the middle, so we're going to test there. And then we want to test, usually if you go one around, that's pretty okay. So then you test f dash of x, so you go back to this curve here, and you test in -1. We get, okay, 3 times -1 all squared, that's just going to be 3. Oh, okay, and 3 times 1 all squared, yeah, that's also going to be 3. What kind of stationary point is this? Check back on your notes. Because we actually looked at 2 types, didn't we? We looked at one that was a minimum. So the gradient should be going negative, then 0, then positive. And we also looked at a maximum where it goes the other way, right? This one doesn't fall into either. And the only time you may have seen this one beforehand was if you probably made a mistake in your algebra and then you got like a positive, 0, and positive. You're like, oh, I must have done a mistake. There's something wrong here, right? If you do it in this situation, you can see it's not a mistake there, right? Because the gradient's positive here. It goes to 0, then it becomes positive again. It's neither a minimum nor a maximum, okay? It's none of those. So what we do is we go to the next point and we do part B, which is identify any inflection points. Because this here is in fact a place where the concavity changes, but it's also where the gradient is 0. Okay, so this is what we're going to do. We're going to do the same thing with the second derivative. There is a stationary point. At 0, 0. Now we don't know what type yet because we haven't classified it. So for part B, we're just going to ignore that, yeah. For part B now, identify any inflection points. This is what we need to do. We're going to take the second derivative Harry, what's that going to be? 6x. Okay. And the same premise, right? At an inflection point, we want to let f double dash x be equal to 0. And so 0 is equal to 6x, x is equal to 0 as before. Okay. And now we want to draw up a little table again. This time though, the only difference is instead of putting f dash of x here, you're going to put f double dash of x. And we're looking for a change in concavity, right? So I know at x equals 0, it's going to be 0. Let's test on 1 and negative 1. Now this time it's a bit different now because you've got 6 multiplied by x. There's no quadratic here. So when you put these values in, negative 1 into here, we'll get negative 6. 1 into here, you get 6. What do you notice? Exactly right. It goes from negative to positive. And it makes sense because when you look at the picture, right, it's concave down here, then it's concave up over there. So there is a change in concavity. Therefore, there is a, now, you could write an inflection point, but this one's a special one. Therefore, there's not only a point of inflection, right, because there's a change in cavity, but we found here there's a stationary point. So we call this, we're very creative with names, mathematicians, a stationary inflection point. It's a horizontal inflection point. And we already found what that point was, it's just at 0, 0. Okay? Questions about that? So for C now, again, you can just do it visually, right? But how would you do it algebraically for a more difficult question? If I want to know when it's a concave down, you've got this second derivative. That's like your concavity function. It's telling you what the concavity is at any point in time. So you could just let f double dash of x be less than 0, and you can solve that as required. So x less than 0 is when the curve is concave down. Right. Now, start off with an easier example just to kind of get us more comfortable with this. Right? Do we want a trickier one?